Get started with 9.5. So we're going to be going over different properties of logarithmic functions today. And I did send this out, this handout that's going to help us. We're going to use these rules. So instead of me writing it all on the board and y'all writing it down, I printed it off for y'all or sent it to you in an email. Okay. So what we're going to talk about first is how to rewrite. And this is going to be using that product rule, that first rule, how to rewrite a product of logarithms as a sum of logarithms. And then I'll show you how they mean the same thing. So let's look at number 1. You have log base 9 of 9 times 81. Okay, we want to, you'll notice on the left side of the equal sign of the product rule, I can rewrite this as the sum of those two logs. So if I'm going to rewrite this as the sum of logs, I'm going to have log base 9 of 9 plus log base 9 again of 81. So this is the answer of this one rewritten as the sum of logs. Now, let me tell you, just to show you that I'm not changing anything. Sometimes we want to see your logs written out as the sum of logs. Sometimes we would prefer to see that as just one log. Okay, but just to prove that these two things say the same thing, let's see what these logs are saying. What is this one? What would you have to raise this 9 to in order to get 9? 9 to the first power. So that log would be 9. Plus, what do you have to raise 9 to in order to get 81? Or in other words, what's this equal to? 9 squared, so 2. And 1 plus 2 does equal 3. Let's look at this one. Let's see, if I multiply the 9 times the 81 in there, I have log base 9 of 729. What do you have to raise 9 to get it to 729? 9 times 9 is 81. You have to raise it to the third power. So they equal the same thing. They are equivalent. You can write it either way. Okay, now I don't want to go over this too much, but that's the answer, right? That's what you're putting in MATLAB. That's the answer, is writing it as the sum of those logs. This extra work was just showing you that they really are the same amount. Okay, let's look at number 2. ln of d times f. Express this one as a sum. So again, anytime you have a product inside here, you can rewrite that as the sum of those two logs. So that'll be ln d plus ln f. Now, these next couple of problems are going to use the power rule on that page. Okay, the power rule says if your logarithm has an exponent, it can be rewritten with this exponent down in front and times that same logarithm. So let's use that rule to rewrite these. On number 3, you have log base n of y to the 20th. So this one can be rewritten with this exponent down in times the logarithm instead. So this is going to be the same thing as 20 times log base n of y. This is going to be the property on Monday that we're going to use to solve exponential equations. Sometimes when you're solving for x, if the x is in the exponent, we're going to use this log rule to help us bring the x out of the exponent. Okay, so just keep that in mind for when we're doing 9.6. All right, same thing on number 4. Before we do number 4, though, remember when we talked about this last class period, the way that radicals can be rewritten as terms that have exponents that are fractions? Remember we talked about the square root of 9 is going to be the same thing as 9 to the 1/2 power, or the 5th root of x is going to be the same thing as x to the 1/5 power. Okay, you can go back and forth between radicals and exponents that are fractions. They're equivalent. Okay, so let's think about that when we're looking at number 4, and it wants us to rewrite this one. We have ln of the 6th root of 7. And it wants us to rewrite that as a product, which means bring down the exponent in front of the ln. Well, if I'm going to bring down the exponent, I need to see the exponent, right? So I'm going to rewrite this as, instead of the 6th root of 7, but ln of 7 to the 1/6 power. And then drop down the 1/6. So I have 1/6 of ln 7. All right, the other rule that's on this sheet that we're going to talk about today is the quotient rule. So you can rewrite logs that are multiplication as the sum of those logs. You can rewrite logs that are division as the difference, which means subtracting those logs. So number 5, you have log base t of p over 9. So again, you're going to do the top log minus the bottom log. You're going to have log base t of whatever's in the top, p, minus log base t of 9. So division can be rewritten as the subtracting of the two logs. Number 6 is the same thing. You have the ln of m over n. So since it's the quotient, I'll use that quotient rule and rewrite that as the difference. So you have ln of m minus ln of n. Okay, now some of these will have multiple properties that we can use, like number 7. Got log base c of x to the 8th, y to the 8th z. So let's rewrite this one. So since these are all multiplied together in there, they're going to be rewritten as the sum. Okay, which means I'll have log base c of x to the 8th plus log base c of y to the 8th plus log base d of z. So rewrote those as the sum. Now you don't want to leave logs that have those exponents. So anyone that has an exponent needs that exponent to drop down. So this one I'll have 8 log base d of x plus 8 log base b of y, and then just drop this one down. So log base b of z. Log base b. Now we've got a fraction. In the top, we've got p to the 4th, q to the 8th. In the bottom, we have m to the 4th, b to the 8th. So I'm going to rewrite this as the sum and differences. The ones that are going to be added using the sum rule is the numerators. The ones that you are dividing by, or in other words, in the bottom of this fraction, are going to have minuses in front of them. Those are the ones that are being divided by. So those are the ones that are going to be subtracted. So let's see, starting off, I've got log base b of p to the 4th plus log base b of q to the 8th. Then when you move to the denominator, that's when you're going to have minus log base b of m to the 4th and minus log base b of b to the 8th. Now, everybody's got exponents. I'm going to bring those down. So now I've got 4 log base b of p plus 8 log base b of q minus 4 log base b of m minus 8. Now, here's something else. Log base b of b. Anytime you have this situation, if the base and what you're taking the log of are the same thing, this whole thing cancels out and turns into a 1. So you really have minus 8 times 1 right there, which means at the end of this, you really just have that minus 8. So why is that? Why does this cancel out and turn to 1? Let's use a number instead of, if those are the same thing, what is that log? What do you have to raise 10 to make it 10? 1. So that's why anytime the base and this number are the same, that whole thing is going to turn into a positive 1. Thank goodness that one's multiple choice, so you don't have to type that all in. If you're looking at that sheet, it looks like it's B. Right, number 9. ln of 4 over 9x to the 9th y. So I'm going to do the same thing. Anything that is below the division line is going to be subtracted. So I'm going to have ln of 4. And then everything else is going to be minus, right? So minus ln 9 minus ln x to the 9th minus ln y. So the only thing that needs to come down is that one exponent. That's ln4 minus ln9 minus 9 ln x minus ln y. All right, number 10. Log of the square root of c to the 9th b. All right, first thing I'm going to do is change what's underneath that square root and instead of saying the square root of all that, I'm going to say all that raised to the 1/2 power, right? The square roots and raising to the 1/2 power are the same thing. So I've got log, and then everything in here, c to the 9th b is being raised to the 1/2 power. So next, since everything in the parentheses is being raised to the 1/2 power, now I'm going to take that into account. So the exponent rules are the same as the exponent rules always are. If you are being raised to more than one exponent, you're going to multiply those exponents together. Okay, so c to the 9th and 1/2, right? The c is being raised to the 9th and 1/2. So if I multiply that together, I'm going to get 9/2 as its exponent. And then d is just being raised to the 1/2. So again, I changed the square root to a 1/2 power, and then they both get the 1/2. Now, what is this going to be rewritten as? Those are multiplied together, so I'm going to rewrite those as the sum of those two logs. So log of c to the 9/2 plus log d to the 1/2. And what's the last step? Bring down your exponents. So I've got 9/2 log c plus 1/2 log d. All right, number 11. It's like this one, and a couple of the other ones all combined on steroids. So I'm going to pause it for a second and let y'all try it. See if y'all can. Okay, let's talk about this one. So we have the log base b of the 4th root of n to the 12th, n to the 16th over b to the 3rd, c to the 3rd. So the first thing, just like the last one that was a radical, I'm going to change this. So instead of everything in there to the 4th root, everything in here is going to be to the 1/4 power. Now, also, just like the last one where we had multiple exponents, I need to go through to each letter and multiply its exponents together. So let's see, I've got log base b. The first one I'm going to multiply together is 12 times 1/4. So if I go straight across from top and bottom, I'm going to get 12 over 4, which just reduces to 3. So the m's exponent is now a 3. The n is being raised to the 16th and 1/4, which gives me 16 over 4, which reduces to 4. So now I've got n is going to be to the 4th power over b is being raised to the 3 and 1/4 3/4. So when I multiply those together, I get 3/4. And that one doesn't simplify. So B's exponent is 3/4 and C's is the same. So now I'm going to rewrite as sum and differences, right? So the ones in the top are going to be the sum ones, the added ones, then minus the ones in the bottom. So let's see, I've got log base B of m to the third plus log base B of n to the fourth. Then the ones that are below the denominator, or not below it, in the denominator, are going to be your minus. So minus log base B of B to the 3/4 minus log base B of C to the 3/4. Now, everybody's got exponents. So dropping down the exponents. So this one will be 3 log base B of m plus, drop down this exponent, 4 log base B of n minus, now look here, dropping down to 3/4. But what is this? I told you it had everything. Log base B of B is equal to 1. So I really just have 3/4 times 1 there, right? So I just have the 3/4 minus 3/4 log base B of C. All right, that is the most complicated one. Now, these next ones are going to be going backwards, which is actually simplifying because you're going to be going from having multiple or 2 logarithms to 1, okay? Like on number 12, this has to express this one as a single logarithm. All right, you got log base B of 19 plus log base B of 27. So they're being added together. So you're still going to be using this sheet, but instead of turning it from the multiplication into the sum, it's giving you the sum of 2 logs and asking you to turn it into the product. That's what, if you have these, this right here, that means you can turn that into a single logarithm and multiply those numbers together. So I'm going to have log base B of 19 times 27. And then just multiply that 19 and 27 together. So log base B of, when you multiply that together, you get 5/13. So the sum turns into the product. Which means on number 13, you've got log of 1,000,000 minus log 10. So what does subtraction go back to? That one goes back to division. Good, the quotient rule. So I'm going to have log of 1 million divided by 10, and then you can go ahead and do that math. 1 million divided by 10. It's going to give me log. You divide something by 10, it just loses a zero. So you're going to have 100,000. Whoops, except it's not high up like that. Okay, this is a two-part question. It's going to want to know what the log is. And then it's also going to want to know, well, what does that equal? What is the log of 100,000? Or in other words, remember, you can just type that in your calculator. And so just type in log 100,000. Now remember what this is saying. If I don't see the base, it's automatically a 10. What power do you have to raise 10 to in order for it to be 100,000? The fifth power. So the log of 100,000 is 5. All right, then remember I took out 14, 15. Go into 16. Got ln of x squared plus 9x plus 18 minus ln of x plus 6. All right, first things first, since that is minus, I'm going to rewrite this as a single logarithm and turn it into the quotient. So I'm going to have ln. In the top, I'll have x squared plus 9x plus 18 over x plus 6. Now, on the last one, at this point, I had 1 million over 10 and just did that division. That's how you simplified this. Okay, I can still simplify this one. I need to factor this numerator. It's a factorable trinomial because if you put it in its factored forms and one of those factors is that x plus 6, then they'll cancel. Okay, so I need to factor what's up here. So let's see, x and x for x squared. Factors of 18 that add to positive 9 would be a positive 9. I mean, not a positive 9, a positive 6 and positive 3, right? Multiplies to 18, adds to 9. And then remember, what was your denominator? X plus 6. So your x plus 6's do cancel. So you are just left with ln of x plus 3. All right, last one. Log of x squared minus 4x minus 21. Minus log x squared minus 9. So again, since it's subtraction, I'm going to rewrite it as the quotient. So I've got log. Up top, I'll have x squared minus 4x minus 21 over x squared minus 9. So let's see if this simplifies. This time I have to factor in the top and the bottom. So the top, it's a trinomial. So how do I get x squared? X and x. Careful with your signs here. What do I have to do? I have to multiply to equal negative 21 equal -4. So remember, if you're multiplying to equal a negative, when you choose your pair, one of those numbers is going to have to be a negative and one's going to have to be a positive. Right? I'm not going to use 21 and 1 to get a -4. Which one of these numbers, if I'm going to end up at -4, needs to be negative? That 7 will, right? So I need a -7 plus 3. Now the bottom, when I'm factoring in, it's a difference of it's two perfect squares here. So x and x still for x squared. Now, what do you multiply? It's the same number. You multiply it together and you get 9. 3 and 3. Your signs are always one positive, one negative. So the x plus 3's will cancel each other. So you are just left with log of x minus 7 over x minus 3.